This is Edexcel Further Pure 1, Calculus, Further Methods in Calculus. And this particular video focuses on Leibnitz's theorem and follows on from the other videos in this particular section. They should be watched in order. Leibnitz's theorem examines the successive application of the product rule. So looking at the product rule, we have y is a product of two other functions, u and v. And the derivative of y with respect to x leads to the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And of course, what we have here, u dv by dx and v du by dx, is we've got a product of two functions. So we can successively apply the product rule. So if I take this first section and look to differentiate that, I'm going to use the product rule again. So I leave the first part alone, undifferentiated, and the second section is differentiated again. Then I leave that second part unchanged and differentiate the first part. And the same is true for the v du section as well. And you can see here, we've ended up getting two terms that are the same. They're the product of the first derivatives of both of our functions u and v. So collecting terms, we end up with this expression. U times the second derivative of v, 2 times the first derivative of u and the first derivative of v, and v times the second derivative of u. If we then differentiate the second derivative to get the third derivative and then to get the fourth derivative, we end up with these two expressions. And looking at the fourth derivative, we can end up seeing that we've got the function u, then its first derivative, then its second derivative, third derivative, and fourth derivative. But against that, we've got the fourth derivative going down to the third, going down to the second, going down to the first, and then going to the function itself for v. In addition, we've got a coefficient of 1, a coefficient of 4, 6, 4, and 1. And if you look at that and then start seeing we've got 1, 3, 3, 1 for the third derivative, and 1, 2, 1 for the second derivative, you should start to recognize a pattern. So we can keep on going with further derivatives, but this pattern will keep on going. And so Leibniz's theorem gives a general formula for the nth derivative of the product y equals uv. So the nth derivative gives us, and this means the sum of all the terms from k equals 0 to n plus 1 terms. And we have the binomial coefficient here, that's just n factorial over k factorial n minus k factorial. Reading through this formula, at either end, either where k equals 0 or k equals n, you're going to end up with a zeroth derivative. So d0u over dx0, well, that just equals u, and the same will be true for v. So we can see at the end points we're going to get the function itself. So here we have two examples to work through using Leibniz's theorem. This first one looks as though it's more of a quotient than a product, but we can end up rewriting that e to the x over cos x as e to the x sec x. Now, to apply Leibniz's theorem, we're going to need to find the first and second derivatives of both of these functions, but e to the x just differentiates to itself, so we've actually got the same function for the first and second derivatives as well. But we do need to find the first and second derivatives of sec x. And the derivative of sec x is sec x. tan x. The second derivative of sec x. Well, we've got a product here, so differentiating sec x, that will give us sec x tan x, and then we've got a tan x to multiply that by with, so we've got sec x tan squared x. Then we leave the sec x unchanged and differentiate tan x, and tan x is sec squared, so that'll give us sec cubed. So now we've got all the components that we need to put into our formulae for the second order derivative. So the second order derivative of e to the x over cos x is going to be e to the x multiplied by the second derivative of sec x, so that's sec x tan squared x plus sec cubed x. Then we need to have two lots of the products of the first derivative. Well, the first derivative of e to the x is e to the x, and the first derivative of 1 over cos x is sec x tan x. And the second derivative of e to the x is e to the x, and sec x is sec x. So if we look through all these, we can see that we've got a common factor of e to the x sec x, and that this first one will yield tan squared x, second one sec squared x, third one will give us 2 tan x, and the final one, well, that's just 1 in there. Of course, we could convert everything inside this bracket to be all in terms of tan using the sec squared equals tan squared plus 1, but we'll leave it like that for now. And here's that first solution written out a little bit more neatly, so if you want to freeze the video you can follow it through in more detail. In the second example, we were asked to find the third derivative of x cubed sine x. So we'll let one function be x cubed and the other function be sine x. Now we need, because we're going to the third derivative, we're going to need the first three derivatives of each function. So if we set u equal to x cubed differentiated gives us 3x squared, differentiated again gives us 6x, and differentiated again gives us 6. So those are our three derivatives of u. V is sine x, differentiating gives cos x, differentiating again negative sine x, and differentiating for the third time gives us negative cos x. So we've got all our independent sections for the Leibnitz's theorem formula for the third derivative. So we can then start putting these values in to work out what the third derivative of x cubed sine x is going to be. So the first section has u, which is x cubed, and it has the third derivative of sine x, which was negative cos x. Then we have 3 times the first derivative of u, which is 3x squared. So 3 times 3x squared gives me 9x squared. Then we need the second derivative of sine x, which is negative sine x. So there's the negative and the sine. Then we need 3 times the second derivative of x cubed. That's 6x. 6x times 3 gives me 18x. And the first derivative of sine x, which is cos x. And that's a plus this time. The final section is the function v itself, that's sine x, and then the third derivative of x cubed, which is just 6. And then I've just collected those terms together to factorise out cos x and sine x. That was Edexcel Further Pure 1, Calculus, Further Methods in Calculus, and in particular Leibnitz's theorem. Next up, L'Hopital's rule.